Alright, we're going to switch this over into gambling, and the first thing about gambling that needs to be calculated out is odds. Now, I'm not anticipating that you're going to go out and gamble, but, just so you know how the world really works. So, the first thing you need to know about odds is the generalized formula. Odds usually are against, so when you see odds, another word that goes with it is against. Oops. Against, whatever. And the odds against are failures compared to successes. And there is a relationship between odds and probability that we were doing earlier. So probably the best thing to deal with is why do we need odds? And the first thing you need odds for is to discuss a possibility, like you're going to make a bet. So let's see here. Let's call him Red. Red is a racehorse whose odds are posted as 6 to 11. Now, that means he has a chance of losing 6 times and chances of winning 11 times. Out of, well, we'll talk about that later. George, I love George. George bet, let's say $50 on Red to win. And Red won. Yay. How much money does George win? Now, of course, he gets his original bet back, so he'll get the $50 back, but we're just interested in his profit. So to deal with this, we're going to work with the odds, the failures to successes. So in this case, the failures are 6, the successes are 11. And all you have to do is take how much he won, or how much he bet, I'm sorry, and multiply, and what you do is you change this into a fraction. Now, this is a ratio, and ratios generally are not written as fractions, but to find out how much you win, you change it into a fraction so you can calculate it. So this becomes 50 times 6 divided by 11. And he's not going to win that much. It's $27.27. But they're only going to give him whole amount, and they might only give him on the 5, so they probably would just send him $25. And the reason he's not winning so much is because the successes are so high. If the horse was like 5 to 1, that means most of the time he's going to lose, and there's this one chance he's going to win. That's the type of horse you want to bet on. But if the odds are backwards like this, small first and big later, you win less than the amount of money you bet. Now, if the horse loses, of course, he doesn't get back his $50. But if the horse does win, he gets his $50 back, and he gets the $27 in profit. All right, so that's how odds are used in calculating winnings for a bet. So how are they related to probability? All right, let's just change it up here. So if we look at probability of an event, the formula for probability of the event is the number of events, the ones you're looking for, out of the total number of everything, in this case, outcomes. All right, we need to change that into failures and successes. So when you're talking about probability, your successes are the ones you're looking for. So we can rewrite this as a success on the top, over. Now when you say total number of outcomes, the events are also outcomes, so they're down here too. So there's successes in the bottom, plus another number. Well, if you're not a success, you must be a failure. So if you want the sum of all your outcomes, some of them are successes, some of them are failures. If you put them all together, they become your total number of outcomes. So the probability of an event, if we look at it in odds language, is successes divided by successes plus failures. And then it shows you a quick way of converting it from a probability into an odd. So for instance, if I tell you that a probability of an event, whatever it is is equal to, let's say 5 out of 36. Rolling 2 dice, probability out of 36. So all you have to do is break this down into this setup, this successes over successes plus failures. So you know the 5 is a success, and you just need to write it top and bottom. Now they don't cancel out and become 1 because the next symbol I'm writing is plus. How many are left over out of the 36 if I take 5 of them away? Well, that leaves you with 31. So when you look at this number up here and the one below are the success. The other number is the failures. So the odds, and always against, but I'm just going to write odds, are failures, 31, to successes, 5. So it's not a hard thing to do. It's actually kind of easy. So what happens if you have, like, the probability of an event is a percent? It's really not hard to work with. Let's say the probability of an event is 15%. So the first thing you need to do is make it a fraction. So this really means 15 out of 100. If you want, you can reduce. 5 goes into both of them, so this is 3 out of 20. Make the numbers smaller, easier to work with. And then all you need to do is write the 3 on the top, copy it down in the bottom, and say what's left over. Well, that would be 17. So the odds of this event, and I'll write it weirdly, it's not really how it's read, but odds of this event against this event happening are going to be failures, which is this number, 17, compared to successes, which is that number, 3. So if you have a probability of an event that is 15%, that's the same thing as the odds are 17 to 3 against it. 17 failures, 3 successes. All right, you can go the other direction also. If you're given odds of an event are 12 to 7, and you know this is failures and you know this is successes, then all you need to do is remember that the probability of an event in terms of odds language is successes over successes plus failures. And then just plug in the numbers. 12 failures, that's going to go in the bottom. And 7 successes is going to go in the bottom and in the top. So this becomes the probability of the event if the odds are 12 to 7 is 7 out of 19. 7 out of 19. So, I mean, it's really, really not hard to work with odds and finding how much you win given a bet. The lottery is written in odds language, but it's usually better to work with it in probability language to find out what we're going to do next.